Good day, viewers. In this virtual class, we're going to look at how to find the derivative of cot inverse, that is inverse trigonometry. And in this case, we're going to look at cots as our example. Here, the first thing to do here is to express in this case, because of the inverse function, we express x as a function of cot y. Okay? And here, this can be written as x over a all over cot. From indices, we have d raised to power 1, the same thing as 1 over d. That's what we've just done here, sir. The next step is we multiply both sides of this equation by cots. So here, cot times y become cot y. Here we have x over a divided by cot times cot. So that cot will be off. Here we have that cot y is equal to x over a. Let's name this as our equation 1. Okay, but what we need to do here, we should also know from trigonometry that cot is the inverse of tan. Okay, so we use that fact that cot is 1 divided by tan. So this becomes 1 over tan y is equal to x over a. Okay, we will try to make tan as subject of the relation here. Here, if we invert it, this become tan y become this will change, become a over x. Okay, that is tan y. We invert it, this the numerator become denominator become numerators on both sides, so that tan y is equal to a over x. Okay, having obtained that, we can also this is equation 2. Then from equation 1 we can make x subject of the formula, and if we do that, x will become a cos y. This is equation 3. Now from equation 2, we use it to establish a fact here that this is, assuming this is our angle, this is angle y, we say that tan is opposite, twa is opposite over adjacent. So our opposite is a, and our adjacent is x. And we need to find the hypotenuse. For us to obtain the hypotenuse, is the sum of the square of this opposite and adjacent, their square root. So here this become the square root of a square plus s square. Okay, so we square this, obtain their square root. That will become the value of line AB from Pythagoras theorem. Okay, what we need to do, we go to equation 3, and we will differentiate equation 3. So equation 3 is this: x is equal to a cot y. That is what the question before us. Then if we differentiate this, this become the x over the y. This will give us a minus a cosec y, or cosec square y. Give us cosec square y. So that is the, if we differentiate cots, the resulting answer is minus cosec square y. So or we might not be able to go into that one. We can do that one on our own. Okay, the x, the y is this. Okay, and what we are looking for here is the y, the x. Something must be done here. This is the x over the y. Okay, then we're going to look at what does cosec means in trigonometry. So cosec is 1 over sine square x. 1 over what? Sine square x. So here this can be written as minus a all over sine square y. Sine square y. Isn't it? Okay. But here, if we are looking for dy ds, we are looking for what? Dy ds. So here, if I'm changing this one to become the denominator to be numerator, and numerator become denominators, this will become the y over dx. Here, this becomes sine square y minus sine square y all over a. Okay. Now we will also go to this fact that what is now sine. Sine is opposite over hypotenuse. What is our opposite? Our opposite is let's establish that fact first. Sine y opposite is a, but here we're having sine opposite is a over hypotenuse. Our hypotenuse is a square plus s square, or s square plus a square. So, but here we're having sine square here. So, if we're having sine square y, that means this become a over the square root of a square plus s square all square. All what? Square. By the time we square this expression, we see that this dy over dx is equals to, if we square this become a square, leaving this square root. By the time we apply the square root to this, everything will be off. This become a square plus s square. And here we say divide by what? By a. Okay. Here we're not true. So here we can also be written that dy over dx is equal to minus a square divide minus a square. This is the minus you follow, minus a square divide a square plus s square. We change this sign to multiplication times this will now divide, this become 1 over a. So 1a will be left here, and here will become a. So dy over the x becomes minus a all over a square plus s square. So this is the derivative of cot inverse of x over a is going to be minus a divide a square plus s square. Okay, assuming we have a function y is equal to cot inverse of say x over 3 here y prime, which is the y, the x will become minus 3 divide 9 plus s square plus s square. That is the derivative of cot inverse. So please, all you help me subscribe on my YouTube channel, and also share this information on your social media platform. Have a nice time. See you in my next partial class.